Hello and welcome to the video. I'm going to be reviewing a data pipeline I'm currently developing, and I'm going to provide some insights into how I am structuring this project. I will likely make this into a multi-part series where I go through various systems and explain the data flow and design intentions between each component. The pipeline I'm constructing is going to be centered around the GCP platform, and we will use various bits of tooling in order to deploy our resources and our data infrastructure into that environment. So let's jump into my GitHub repository and to give a high-level overview of the architecture. Bearing in mind some of this is a work in progress and we will be developing it in the duration of the series. So as a summary for this pipeline, it will be ingesting data from the chess.com API, which houses data in a variety of endpoints. However, for our project, we are specifically going to be targeting the player endpoint. And the reason for that is because it houses information on historical games that players have played. And in that game archive data, it's going to feature a variety of data points such as chess elo, chess openings, chess moves, formats, opponent data, etc., etc. And I think it's going to be interesting to pull that data in and analyze it in some kind of visualization tool. In terms of the CI/CD process, our Git repo is of course going to be the central location for managing change to our infrastructure. We're going to be leveraging GitHub Actions in order to drive Terraform, which is going to be used to deploy our key GCP resources. GitHub Actions will only trigger when we're pushing into the main branch, so we can safely develop on our development branch without impacting our production system. But in the event that we do push the main, we're going to be using the workload identity federation in order to authenticate with GCP. So we'll be requesting access from the identity federation. It's going to generate an ephemeral access token, which is impersonating a service account that we have set up on GCP with the right access. And it will go ahead and deploy our resources using the relevant Terraform steps. Currently, we're only deploying one resource according to this diagram, which is this chess deployments GCS bucket, which houses our scripts for our pipelines. However, there's going to be plans to incorporate more deployments for more resources, namely cloud functions, pub subtopics, and what have you. Moving on to the high-level architecture diagram, I will briefly explain how the data ingestion system will operate. We have a cloud scheduler job which will run once a month, and this will be used to trigger a cloud function which will spin up a virtual machine to run our pipeline. It will be pulling down a Docker image that has all the environment set up. So it's going to have the Google SDK, our Python virtual environment with the Python library installed. And additionally, we will be loading our scripts from the into the virtual machine via this GCS bucket chess deployments. So we'll be able to run our Python pipelines to do our data ingestion. So once we have our ingestion script executing, we'll start making requests into the chess.com API. And first we'll be targeting the leaderboards endpoint in order to get a list of all the top chess players on the platform. and we will feed this into a series of requests to hit all of the player endpoints to get all of the game archive data for each of those players in the relevant date period we're ingesting for. We will only be ingesting 200 HTTP responses into our GCS bucket, and we're going to be discarding anything that's not a 200 response. The reason for that is because we don't want to be saving invalid data into our GCS environment, and it minimizes how much cleanup we need to do in our bucket, so it makes it easy to maintain our data and it makes it very clean. But once all of those requests are saved in GCS, we can go ahead and run a shutdown script and terminate our virtual machine, and we don't need to be incurring extra billing costs for operating a VM that's doing nothing. So there you go. And yeah, that's all we got up till now. There's a lot of work still in progress in order to fully flesh out this data engineering project. Namely, I'm working on a transformation script to take data from GCS and load it into BigQuery. And there's one more thing, I still need to figure out on how to automate my pipeline execution system for orchestrating the ingestion / transformation systems. However, in the meantime, I will likely continue to upload videos on the components that we built up to now, and I'll provide a more detailed explanation on those things as we walk through them in this video series. Anyway, thanks for watching, and I'll see you guys in the next one.